Well, students, Bismillahirrahmanirrahim. Today's topic is about half-life and its measurement. It is the fifth topic of chapter number 18, and the points to remember about is this. The process of radioactivity, as I've told you before, is random, is spontaneous. And the rate of radioactive decay is proportional to the number of unstable nuclei present. The points to remember here is that the process of radioactivity is random, number one. Number two, the rate of radioactive decay is directly proportional to the number of unstable nuclei present in a certain sample. So the lifetime of the unstable nuclei is unlimited. The lifetime, therefore, is unlimited and difficult to measure. By this we mean that how much of the sample will decay after a certain time. So this problem is solved by radioactive decay rate can be measured by half-life. By half-life we mean the time taken during which half of the unstable nuclei disintegrate is known as half-life of the sample. The half-life of the sample is how much of the unstable nuclei, if they decay half of it, that is in a certain period of time, that is known as the half-life. I repeat again, the time taken during which half of the unstable radioactive nuclei disintegrate is known as the half-life of the sample. For example, radium-226 has a half-life of 1620 years, 1620 years, which means that half of a radium-226 sample will be converted into other elements by the end of 1620 years. That is, in the next 1620 years, half of the remaining radium will decay, leaving only 1/4 of the original amount of radium present, and so on. This can be explained with the help of a diagram. Suppose this is the N is the number of nuclides that are decaying, and on the x-axis we have taken the number of years. So if 1620 years are taken for half of the sample to decay, let's suppose that in the beginning there were 16 samples. So after 1620 years, half of them means 8 of the atoms will decay and 8 will be left behind. In the next 1620 years, that means total after 32-40 years, only 4 atoms will be left behind. And then after 4860 years, only 2 atoms will be left behind. So this is how we calculate the time taken for a certain sample to decay into other nuclei. The formula which we can use for this is, if the half-life of a radioactive element is T1/2, then at the end of this time, the number of atoms in the sample will become half, means that will be half of it. So after 1620 years, if the samples are 16, they become 8. So if it is T, then becomes half of that. And after time 2T, twice, this was half T, T1/2 for the first half-life, twice that time, second half-life, means the number of remaining atoms will be 1/2 multiplied by 1/2 will be 1/2 squared is equal to 1/4. And after 3 times the half-life, the number of atoms will be 1/8. And after T half-lives, the number of atoms will be 1/2 times to the exponent T. So this means that if N0 is the original number of atoms present in a certain sample, and after time T half-life, the number of atoms will be equal, can be found by the formula N is equal to N naught, which is the original number of atoms, multiplied by 1/2 in times T. So radioactive decay does, now this is a very important thing to be remembered. This formula can be used to find out the time taken, and the point to remember is that the radioactive decay does not depend upon the chemical composition or reactions. It does not depend upon the temperature, pressure, electric or magnetic fields. So I would like to now go over the points again. That is, the process of radioactivity is random. This you have to remember. You cannot calculate when a certain sample will be decaying. It is just spontaneous. It happens suddenly. And the rate of radioactive decay is proportional to the number of unstable nuclei present in a certain sample. The more the number of unstable nuclei present, the more will be the rate of decay. So the lifetime of the unstable nuclei is unlimited and difficult to measure. Radioactive decay rate can be measured by using the term half-life. By half-life, it means the time taken during which half of the sample decays into some other element. Radium-226 is one of the examples. It is a radioactive element. It is an unstable atom. So it has a half-life of 1620 years. And after 1620 years, half of the atoms present in a certain sample will be decaying into some other element. And by the end of the next 1620 years, another half will be decaying, and then the third half-life after about 4,860 years, the third decay will take place. This has been shown with the help of a diagram. On the x-axis you have the time, and on the y-axis you have the number of nuclei that decay. So if 16 atoms are present at a certain time in a sample, just for the example, actually there are billions and billions of them, then after 1620 years, half of them will decay and 8 will be left behind. These 8 will then again decay after 3,240 years into another half. Then 4 will be remaining, and then 4 will become 2 after 4,860 years. So the formula that you can use for this thing is, if the half-life of a radioactive element is T1/2, then at the end of this time the number of atoms in the sample will become half, that is 1/2. After time 2t, it will become 1/4. After time 3t, it becomes 1/8. And after time t, half-life of that becomes 1/2 into t times. That is the number of times it has been decaying and decaying and decaying. So the formula used for this is N is equal to N naught, the original number of atoms, multiplied by 1/2t. So this is a very important relation that you must remember, that what is the formula that is used for finding out the half-life of a certain element. And another thing to be remembered is that radioactive decay does not depend upon any composition of the substance. It does not depend upon temperature, pressure, electromagnetic field. It is just spontaneous, it is random, and it keeps happening on its own when the nuclei becomes in an excited state. So with this, I come to the end of it. Your assignment is, please go over this topic, try to remember the formula, the process, and then try to write it down and send it to me by WhatsApp. Thank you.